All right, so I might have gone a little overboard in trying to calibrate watt meters, but I wanted some new test equipment anyways. As you can see, I like test equipment. So anyways, I have an Agilent E4418B power meter. Picked up this Precision Bird 40 dB 300 watt attenuator. This one was previously used in the cell phone industry, and you can see their little calibration table here. It was calibrated, looks like, by Tektronix back in 2010, but it hasn't changed, or does, they typically don't. But those at 450 meg, that doesn't help me out because I'm calibrating an HF power meter at 14.2 megahertz, a LP500 specifically in a pair of power couplers. So what do you need to do this? Well, you need to know what your resistance or your attenuation is, and you have to use a power meter. So first I measured the output of my signal generator, creating exactly a 10 dBm signal out of the signal generator, and that's through the loss of, measured through the loss of my adapters, my jumper cable that I'll be using to the radio, to the attenuator and output. So I measured to here, plus 10 dBm, and I used an HP 8482A power sensor, calibrated power sensor, to give me exactly 10 dBm on the output of the generator through the cable. Then once I know I have plus 10 dBm, I'm measuring now the output or the attenuation with this low level HP 8482 or 8481D. This has the H70 option. H70 option gives it a calibration chart down to 100 kilohertz. And if we can see here, we can see on the meter minus 29.99 dBm. So what you do is you put an offset. So we know the input's exactly 10 10.00 dBm. And we're showing now 29.99. So that gives us an offset of 39.99 dBm. So we can turn the offset on. Now you can see when the offset's on, it's showing that the correction for the attenuator and the loss of the cable, the output of my generator is exactly 10 dBm. By knowing all this, I can switch this side here to watts now, and I can watch, or I can move this cable over to the radio, which I did, all to both power couplers, and I can calibrate the couplers to measure what the power meter shows. And this attenuator is slightly affected by temperature, but not much. That's why I got this big 300 watters, because it's going to absorb, it's going to stay pretty well consistent in temperature. And you just make your measurements quick, and you make sure you don't get it too warm, and your attenuator won't change too much. And I checked it before and after and saw a difference of a couple hundredths of a dBm, but I went ahead and did a recheck after it had warmed up some. And I can tell you now that my LP500 power couplers are very, very accurate. Plus or minus 1 watt at 200 watts on the low power coupler, and plus or minus 3 or 4 watts at about 500 watts on the high power coupler, which I have on the output of the amplifiers. So there you go. All right, just to show you, after I have the test setup over here, all configured and calibrated and offsets entered into the power meter correctly, including line loss of my jumper cables and everything else. I'm going to transmit now 14.2 megahertz. We got 5.1 watts on the watt meter. We're showing 5.06 watts on the power meter. We're going to turn this up to, there's 103 watts, 102, 103, 102 watts on the Agilent. We're going to turn this up to If I get the right knob for power. There's 204 watts, 204, 205, 204 watts on the Agilent. Yeah, I'd say it's pretty close.